So, like I said, we'll do the maths now, and tomorrow we'll move the class an hour early into the assessment support slot. What's that, 2 o'clock, is it? And what we'll do, do you want to bring your laptops tomorrow so I can check it and yeah?
We have our
Your coursework.
the math.
Yeah. And then in the second class, we can have a look at either maths or physics labs. I'm not sure yet. Anyways, we were talking earlier, KJ, and we said we'll have a maths tutorial in this hour. So, Jerry, you've been waiting to ask the question, so let's start with that question. Jerry's going to tell us what page to look at. Page 50. Okay. 50. What question? 2A. Can you read out 2A? What is it? Yeah. Yes. Give me an example, yeah? Inverse sec. Inverse, yeah? 1.192. Yeah. Okay. Let's have a look here. So we'll call this equal to x. And we want to find x. So we can say 1.1924 equals sec x. So 1.1924 equals 1 over cos x. So cos x equals 1 over 1.1924. So x equals cos inverse 1 over 1.1924, which is an angle.
When I found that sec or sec inverse, that becomes sine inverse sin x and 1 over x.
Yeah.
Yeah, right? So if I write...
You can do it directly. That's fine.
I don't need the...
No. Is that okay, Jerry? Are you sure? Yeah.
50 number 3.
Same page?
Same page.
Well, let's just give people a minute to write this down, and then we'll look at number 3.
The graph.
The graph, yeah. What the heck are those?
Cookie
It's chocolate.
with a blueberry.
Was that blueberry? I thought it was peanut.
Yes, it's blueberry.
If you can't tell the difference between the blueberry and peanut, it makes it sound like it's not really that good. Do you know?
It's blueberry.
Like if I served you a sandwich and you said, I can't tell the difference, I can't tell if it's beef or chicken or pork, like, well. The beef burger was nice.
You want one?
No, I had dessert after my burger and chips, so I'm stuffed.
So nice. Very
Stuffed.
good.
You make it.
No, I'm stuffed. Okay, which one, Chrissy? Which one?
Inverse.
Yes, give me an example.
CSC inverse.
CSC inverse x.
Y is
Yeah, so you want to plot this. To be a bit clearer, this is cosec inverse. You want to plot this. Now, before you can even plot this, it's actually sometimes helpful to plot y equal cosec x. which is 1 over sine x. And it's sometimes even helpful then to plot y equal sine x. Okay, so I'm kind of going to make 3 graphs to help us get to the answer here. So we'll stick to just 0, we'll go to 2 pi, pi, minus 2 pi, minus pi, and there's the breaks. And there's 1, and there's minus 1. What's wrong? What do you need them for?
I can see them.
Well, why don't you move?
What?
Okay.
Chew. Do you mind moving there? Little Jerry can't see. Thank you. Better, Jerry? Okay, can I continue?
Yeah.
So this is the graph for sine x, as you know. Goes up, down, and back, and then like this. Now we don't want sine x, we want 1 over sine x. In fact, we don't even want 1 over sine x, we want the inverse of that. So we'll have to do it bit by bit. What's 1 over sine? Well, we know that it will go shoot to infinity when sine x is 0. So it'll break here and it'll break here. But then also, what happens when you have sine x is 1? What is 1 over sine x? Well, what's 1 over 1? It's 1. So actually, you see this point here, and this point here, they're the same for sine x and 1 over sine x. And these ones break to infinity. So the graph, I think this will shoot off to infinity, this will shoot off to infinity. Here, this will shoot off to infinity, and this will shoot off to infinity, so it'll look like this. Oh, I don't quite have that right, do I? No, that's it. There's shoots down here, shoots up here. So I'll have to draw that again. Do I have that right? I think I have that right. Yeah, so it's like a parabola here. There's like a parabola here. There's like a parabola here. It keeps repeating like this. Okay. Now I need, if this is y and this is x and this is y equals cosec x, I now want to make a new graph. Y equals cosec inverse x. Right, this will be a little bit tricky, but you can work it out like backwards. So it's kind of like, this is a bit like the y for this graph, because it's the inverse, it's the reverse. So for example, what's the value when x is 0? Well, if I look at this graph, when is y 0? When will y be 0 on this graph? Never. So there's actually no value at 0. When will y be 0.1? No. In fact, for everything between -1 and 1, there is no value. Now, when I ask you 1, you actually have a choice here. Could be this or it could be this. So we usually take this value. So the x here is, what's this one, pi over 2, isn't it? So that means at 1, we get a value of pi over 2. And then, if I increase it, I'll get bigger values. No, sorry, I'll get smaller values for x. So if I increase here, I get smaller values. So I think the graph will look kind of like this. And then on the other side, I think, it will look something like this. So I think the graph will kind of have this shape here. Now, I'll have to open the graphing program.
No, that's great. I found the internet. Looks,
You typed it, yeah?
yeah, it looks like that, but I don't know how.
But it's not easy to work that out, because you actually have to think about many different things to get to the answer. Now, what some students do for the exam, which I actually think is fine if you want to, in the exam, they sometimes ask you for cos sec inverse, and cotan inverse, sine inverse, cos inverse, and tan inverse. So you could just learn those 6 graphs if you feel it will be quicker for you just to learn those 6 graphs rather than thinking about how to make those graphs in the exam. But they have asked for the inverse graph in the exam. I think I've seen them ask for like a sine inverse, but I don't think I've seen them ask for like a cosec or a sec inverse. I don't think so. But let's just double check this one.
Teacher.
Yeah.
So by inverse, we just flip the x axis and y axis.
Yeah, they swap places. Now that's easier said than done. Let's have a look here. Yeah, there we go. Yeah, you get the idea. It is actually the same.
Can you show the sec and cos too?
You want to see the other ones?
Yeah.
Yeah, which one do you want to see?
Sec.
Cotan inverse?
Yeah, cos inverse.
Okay, so here's cotan inverse. It's a bit weird. It looks a bit like an exponential, but it has a limit, it looks like. If I squish it a bit, you see? It kind of limits between 0 and pi. Yeah. And do you want sec inverse? What's the abbreviation for sec? Is it this? Yeah, I think so. Again, it's limited between 0 and pi, but I think here this is pi over 2, and I think you can't quite see this on the graph, but this may be... No, actually, why is it stopped there? Is it a root here? This might be a root here at pi over 2. The graph isn't quite continuing. Let's zoom in on it and find out. Where's center on cross? Center on cross. Zoom in.
One.
Yeah. 1. Okay, there's a root at 1. I'm glad I did that. So that means... Which graph was this?
Sec inverse.
So that means sec inverse 1 is 0.
But why it doesn't look like 1 has a root when you zoom up?
Oh, it's just a limitation of the graphing program.
Oh.
This program is very basic. It's quite impressive what it can do. Like, it's only, the program is only like 6 megabytes. It can do a lot for 6 megabytes, so I'm not going to hold this against it.
Teacher, why would say if
Oh, that's just the way this program understands inverse. It's also the way you say it in America. You don't say sec inverse, you say arcsec. Yeah.
I like the arcsec.
I do too, actually. I do too. Because it's less confusing.
But they also have like hypo something.
Oh yeah, we have that here too. That you studied that at university.
I'm not sure.
No, you will here at university, yeah. No, it's not on this maths course, yeah. Okay. Jerry, does that answer your question on the lesson, page 50? And Chrissy?
I hope. No,
Yeah, good. Go ahead, please. What page? What page?
What?
Jerry, what page?
I don't know.
Okay, fine.
Could you please,
KJ, do you mind passing that?
this
What am I checking here?
why is it equal to that
Am I looking here?
Yeah.
Yeah, what's your question?
at what time? got it.
Yeah.
Yeah, I know that.
What part don't you understand?
The last three parts. Why are they equal?
Come here. Show me what you don't understand. What don't you understand?
Come on, John.
X equals 1.
Yeah.
Y fx minus 1 equals 1.
Yeah, do you know what this means, F inverse?
Yeah.
Here, I'll do this. What's this? Fx equals, is this sec? Okay, you can sit down. Let's get the inverse here. Now, Jerry, do you know what this is?
Yep, no.
Ah! Can I see what page that was on, please? Yeah. Jerry, did you do lesson on page
Yes.
18.
Have a look at page 18.
Whoa.
Did you do this lesson, or did you miss it?
That's nothing.
Did you do page 18?
Yep.
Are you sure?
Yep.
Yeah.
I'm sure he was there.
So that's what I need to do here, page 18.
Do it again.
Yeah, so here we have y equals sec x. So that means sec inverse y equals x. I forget what the question is. Oh, it's to find the inverse, is it? Well, actually, no, I won't do that. Then I have y equals 1 over cos x. So cos x equals 1 over y. So x equals cos inverse y. So we have found f inverse. So therefore,
1 over y.
oh, thank you. F inverse x equals cos inverse 1 over y. So therefore, if f is sec x, then f inverse is sec inverse, is sec inverse x, which equals cos inverse 1 over x. So this is the result, that sec inverse x is the same thing as cos inverse 1 over x. It gets a bit confusing at the end.
Yeah, that's the part confusing.
Yeah. Yeah, but remember, in the process of finding the inverse, the last step is to swap x and y. Where? Here? 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 Where?
The second last
Here? Yeah?
you said cos inverse 1 over y.
Well, this is 1 over x.
It's white.
That's how you find the inverse.
You see, what I did, Monica, going from here to here is I swap x and y.
For taking the x inside, come out.
It's the process for finding the inverse. If you don't like that process, there is the other process we had. So do you remember, we start off with x. If I said fx equals, what was it, sec x? Which is equal to 1 over cos x. So you start off with x, and then you get the cos of x, and then you get the 1 over the cos of x. And this is called function f of x. Now I would like function inverse of f. So what you do is you start at the back and go opposite. So the opposite of 1 over 1 over something is actually still 1 over. That's actually the reverse. Now, think about this. If I say add 2, the reverse is minus 2. Multiply 2, it's divide 2. But if I say 1 over x, the reverse of that is to do it again. It brings you back to x. And then the reverse of cos x is cos inverse. So we get the result, the inverse is cos inverse 1 over x. So because f is sec x, it means sec inverse x is then cos inverse 1 over x. That's the other way to get the inverse. We have 2 ways. Yeah. Is that okay now? Is that, yeah? It's okay? Okay, good. Right, I believe there might have been another question for the tutorial. Yeah, what page now? 52, please. What is 52, Monica? Wait, hold on a second. What number on 52? 19C. Okay, Lee?
But how f inverse s equal to sec inverse s?
I'm so confused.
I mean,
If I said f is equal to g,
yeah.
then f inverse will equal g inverse.
Okay, what is f equal to g plus 1?
Okay. If f is equal to g plus 1, then f inverse is the inverse of g plus 1. Whatever that is. Yes? Continue. Okay, can you read that question out, Monica, on the next page?
Simplify
Yeah.
into a compound number. 5 plus 8 plus 12 by
Right, 5 cos
8
a.
plus 12 by 8.
Is my answer wrong at the back?
Yes.
Is it wrong, or just that there's a different answer? Because there's more than one answer.
It's I know there's a sign answer, there's a cross answer.
What answer do I have at the back?
You have 13 plus a minus.
I have a cos answer.
Yes.
Okay, so let's try and go for a cos answer then. So I'm going to change this into, I'm going to draw a triangle. I'm going to call this B. This is 5, this is 13, and this is 12. Yeah? So this would equal, if I take out the 13, this is equal to cos B cos A plus sine B sine A. And this is equal to 13 cos A cos B plus sine A sine B. And that's equal to 13 cos A minus B. Now we still have to work out what the B is. So can someone just hit in tan inverse 12 over 5? Does it look like I'm using degrees or radians?
53.
Degrees. What's that, 53 or something? Tan inverse 12 over 5, please?
67.38.
Cos inverse A minus 67.38.
Exactly. So your answer is
What's my answer to that?
minus 55.4.
Oh. So I typed the 65 instead of the 67. No big deal.
Okay.
So I...
why inverse?
Why inverse? Oh yeah, I don't know how that landed there. Yeah.
And in the exam, it's okay to have sine.
Oh yeah. You see, you actually have quite a choice here. You could express the answer as a sine as well.
Stephen,
Yeah.
I have 67.38 minus 8.
That is actually the same thing because cos is an even function. Yeah. Any other questions?
Yes.
Yeah.
On page 54,
54 now, please.
number 2A.
54, 2a. What is on 54 now?
Double under.
2a.
Yeah.
Okay, let me just give people a minute to write this down. Ready, Chew?
Oh.
Okay.
2A.
Is 2a a good one?
Yeah.
I start with B.
Alright, let's start with 2a. Read it out to me, Monica. Yeah.
If sin 2a is 24 over 25,
Sine 2a is 24 over 25, yeah?
what is the value of sin a? A and 2a are the two.
Okay. This doesn't look too
The
bad.
one that you're squaring. Okay,
You have to square.
yeah.
Let's see what happens. So this is going to be 2 sine a cos a equals 24 over 25. So this means sine a cos a equals 12 over 25. Divide both sides by 2. Yeah. Now you actually have a couple of choices here. I think one strategy would be to square everything. That's 144 over 625. Now we're not too far away from the answer because we actually want sine. So sine squared is actually sine. It's the cos squared we should actually change into 1 minus sine squared. So this will be sine squared 1 minus sine squared equals 144 over 625. So this means sine squared minus sine 4 equals 144 over 625. So that means 625 sine squared minus 625 sine 4 equals 144. So 625 sine 4 minus 625 sine squared plus 144 equals 0. Now this gives us two factors here. So it's definitely going to be a sine squared a, and it's a minus, so that should be a minus there, and sine squared a, and that's a minus there as well. Can I have the calculator for a second, please? And I'll just try and... Now, wait, I'll tell you a little trick here now in a second. Shh, no, you don't... No idea what my trick is going to be.
Calculator.
Well, that part is obvious.
Teacher, can calculator do this for degree 4?
Quiet there. So I have 25 sine squared a minus 9 and 25 sine squared a minus 16. Now you might say, how could I do that? Well, I could use the minus b formula, but a sneaky little thing you can do here. The question says, do not find a. But you realise you could be a little bit sneaky here. What you could do is secretly find a from this formula. Because you could do sine inverse 24 over 25, right? What would that give you? 2a. Yeah? Then you divide this by 2, what do you get?
A.
And then you get the sine of this, and what have you got?
And
And then you square it. and then you have sine squared a, which is actually one of the, when I did this on the calculator I got 9/25, so I knew that that must have been one of the solutions here. Sneaky. Sneaky. So you have two answers here. You have sine squared, actually you have 4 answers here, because you have sine squared a equals 9/25, and sine squared a equals 16/25. So your 4 answers are sine a equals minus 9/25, or 9/25, or minus 16/25, or 16/25. Now in fact, oh sorry, yeah. So it's actually minus 3/5, or 3/5, or 4/5, or minus 4/5. Now, straight away, you can reject 2 of these answers, because I tell you a is acute. So sine a
Positive.
must be positive. So this one's rejected and this one's rejected. But it seems like you have a choice here, but you don't, because I tell you 2a is acute. Now if you use this value for a, then the angle you get for 2a will be more than 90. In other words, this angle is too big to be acute. So it's only this is the answer.
How do we know that?
You could just do sine inverse each of those fractions, and you can see that, what's sine inverse 4/5? It should be more than 45 degrees.
Oh, I'm in
Yeah.
reading.
52.
Yeah. So if you use sine a is 4/5, then sine 2a would be negative. It won't be acute. It has to be 3/5. Now, if I change the question and I said a is acute and 2a is obtuse, then the answer will be 4/5, which gives me an idea. I think I will do that next time. All my questions are probably acute, is it?
Yeah.
Most of them, yeah. Will I do this? Will I?
Yeah.
Yes, just make it.
It's easy for you to say because we finished this lesson.
Yeah.
Maybe I will.
For Bruce.
For Bruce. For Bruce.
For Bruce future.
Yeah.
What's gonna happen?
No, I won't tell him it was you guys.
He was
He
checking the other person.
see the record version.
He won't. Okay, what else for the tutorial now?
Number it's 1.
Still,
Yeah.
did you say sine inverse a, sine inverse 4 or 5 will be more than 90?
I did not. I said more than 45.
45.
Yeah.
That's too big.
Number 1
We have a class with-
In which lesson?
Number
Same
1.
lesson. Okay.
Yeah.
Chrissy, please. 1F on this lesson, yeah? Okay, let's have a look at that. Can I scroll down?
Okay.
Yeah. Okay. 1F. So what's the question?
If sorry, it's 1. Yeah, it's 1. If cos A.
You
know what happened in my question when I wrote it, I wrote an
you withdraw your question. Question withdrawn. Cleaner.
Now how to pronounce that one? Cleona or
No, it's not Cleona. Cleaner.
I already.
without the C at all.
Am I not saying the
No,
same?
it's
Leona
Cleaner.
or Cleona.
But why there's the O in the name?
Cleona.
Cleon.
Like O'Brien.
Or call them.
How do you say this name?
Stefan.
Johan.
Johan.
Simon.
Shiva.
Johan.
Siobhan.
Shiva.
What?
Wow, that's so cool. Do it again.
Siobhan.
Whoa.
Siobhan.
Nice name, Shivan.
It seems like so bad for the Korean.
It's like Yvonne.
And this one? Avian.
Avian.
Well, that's a bit different.
Yeah.
What is human and this avian?
These are Irish names.
How to pronounce BH?
B, yeah.
Big.
Super.
Yvonne.
Avian, yeah.
Hey, change your name spell.
You can't, these are both girls' names.
Oh. Yeah, take that one. No way.
You see, the spelling in Irish is different. Like, this is the spelling of Sean.
Oh, we know.
You know this one, yeah.
Yeah.
What is there?
Where's our scene?
Sin is not just there.
Weirdos. Okay, so, is there more tutorial questions?
I have a question that should be topic a long time ago.
What topic? Oh, that's not that long ago. Let's do a Newton-Raphson. Which?
I have two questions.
That's fine.
You can teach remember.
What page? Guys, Lee, we're looking at Newton-Raphson's lesson.
Yeah, that's Newton Raphson.
Which question?
Number page 40.
40. Question 6. Page 40. Question 6. Okay. What's the function?
So x
e to the power of x
minus 1 equals 0.
Solve it.
To
Okay. Let me open up my calculator. We first have to estimate roughly where the answer is. So let's see. If I calculate f of 0, I'll get minus 1. And if I calculate f of 1, I'll get 1.718, I think. So clearly, that's right, isn't it? Clearly, there's a root somewhere between 0 and 1. And it's not 0 and it's not 1. Between 0 and 1. Yeah? So I will start at 0.5. And Newton-Raphson says the next value, it will be this minus, now on the bottom is the derivative, which is a product rule. So that'll be exn plus xexn, and on the top is xn exn minus 1. So let's see what the calculator tells me is going to happen here. So I'll start with 0.5, and then I have x minus that, and that, and that, and that, and that, over that, whew, that, and that, plus that. Right, so x1 is 0.571. Oh, we're not finished yet because we don't know how accurate we are. x2, 0.567. Okay. Now I think I've hit 2 decimal places because x3 is 0.567 as well. So let me just do one more. Yeah, it's actually barely moving. I think, yeah, after a couple of steps we see very clearly it's 0.57 to 2 decimal places is the solution, without a doubt.
Sure.
Yeah.
When we're doing this kind of question, we can just do it like this: x1 equal to what, x2 equal to what, without rewriting it anymore.
It's not clear because, like I said, the main problem with the exam is that it's to keep getting different people to write the exam. And so different people write the marking scheme in different ways. So some people will say, if the student does not show the work here, then you can give them the marks assuming that, you can assume that they did it right. Whereas some will say, you must show your work. My take would be, you should perhaps look at how many marks are going for the question, and you need to think about, where will I get the marks? So for example, if this was a 4-mark question, for example, this is a 4-mark question, you automatically have to get 1 mark at the end for getting the right answer. So there's no choice about that. And then it feels like you should get some marks for actually having the right formula. Then this work here about proving that there is a root and figuring out a good starting point, that seems like it's 1 mark. But this is where it could change depending on who's writing the exam. So somebody might write the exam to give this part 2 marks, or somebody might write the exam to give this here 1 mark, and they might actually say, show workings. Now, I think really the usual rule in the exam is, if there is a mark going for your workings, they have to say it in the question. Because you can quite easily do this on the calculator without the need to write down everything again and again. So maybe when we have a look at exam papers, we can see what the more recent papers are doing. But the person who is writing the exam this year, I don't know. I have a suspicion it's the same person that's writing the physics exam.
What is nuclear?
I have a question.
Yeah.
I mean, if I don't choose 0.5, like if I choose like 0.4, 0.5.
Well, in the exam, they would tell you where to start.
Oh, okay.
And they would actually say, show that there's a root. But then the second part, or the next part of the question would be say, usually in the exam what they do is they have you start at one of the ends. So they'd have you start at 0 or 1. But I feel that's a bit silly because we know the answer is somewhere in between, so I want to start in the middle. And you can see I wasn't actually too far away. Like starting at 0.5, I only have to go to 0.57 and I have an answer.
This is number 10 and exam question.
What's number 10? What's number 10?
Also 11.
Number 11 we did.
We did 11. Number 10 is number 10 could be an exam question, but they would do it as a multi-part question. So number 10, part A would be to find the derivative. So if you start off with a power 5 equation and you differentiate, what power equation would you have? 4. And then part B would be show there's a root between blah and blah. And then part C will be using Newton-Raphson's rule, find the root. And then they could extend it further. You know, they could say part D might be, and by using your root, use long division to find the other 3 roots. But I don't think they would do that for the exam, because if you have a power 4 equation and you got 1 root using Newton-Raphson, then when you divide it, you'll be left with a cubic, and that's still difficult to solve. So I don't think, I put it down as a power 5. If it did come up in the exam, I would see it more as a power 4, because a power 4 differentiates to a cubic. Yeah. Questions?
Oh.
What? What?
No, I mean like x1 is 0.57 and x4 is 57.
Yeah.
And this is x3 is 0.56.
Yeah, well, x4 is really 0.567. I had to round this through decimal places, yeah. Yeah, 567 is more accurate. Anything else, ma'am? No. This is okay now? Yeah. Let me think. And also in the exam they actually tell you how many times to use Newton-Raphson. Typically they say once or twice.
Oh,
Yeah. No, in the coursework, didn't we have to choose how many times?
Says only once, and then the second time they calculate it.
Yeah, but the and, the number of steps, like here I did it 4 times. X1, X2, X3, X4.
Okay.
I'm saying in the exam they'll specify how many times to apply the formula. Yeah? Is that okay? Is there any other questions on the tutorial? The train's leaving the station. All aboard. Tutorial Express is leaving the station.
Please leave the door.
No,
it's closed.
yes, yeah. We needed like a if have you taken the train in Ireland? It makes a very distinct beeping sound when the door closes. It goes turn, turn. Have you got it? Now train's leaving the station. Toot the horn. Tutorial Express is left. Maybe next week then. Okay, so that's fine with the tutorial then. Let's stop this video.